You're listening to AI Podcast. Today, we're digging into a new EMNLP paper called Generator Assistant Stepwise Rollback, or GA Rollback, for large language model agents.
GA Rollback sounds like an undo button for AI. What's the headline here?
Pretty much that. Big picture, the authors add a second model, an assistant, whose entire job is to watch the main model, the generator, as it works step by step. If the assistant spots a bad move, it doesn't just complain. It tells the agent to rewind to the moment before the mistake and try again with guidance.
So it's like having a co-pilot with a DVR remote. They see something off, tap pause, scrub back a few seconds and say, let's redo from here.
Exactly, and that matters because most agent frameworks today are one pass. Once a thought or action goes into the running transcript, it stays there, even if it's wrong. Those errors then echo forward and poison later steps.
Who's behind the work?
Xingzuo and colleagues, with Xuefeng listed as the corresponding author. The team's mainly from Harbin Institute of Technology in Shenzhen, with a collaborator from Queen Mary University of London.
Got it. What problem did they set out to fix beyond just mistakes happen?
They focus on error propagation in step-by-step agents like React. Imagine a household robot that misreads butter knife as knife. If that thought is treated as true, it tries to pick up the wrong thing, then the next action assumes that worked, and by the time you notice, the whole plan is off. Rollback's promise is to catch that moment and roll the scene back before the bad assumption hardens.
Right, and lots of papers talk about self-correction. What's new here?
A couple gaps. First, many self-reflection methods clean things up between attempts or at the end of a trial, not during the trial, so the damage still spreads in real time. Second, they often lack a rigorous, stepwise judge for the quality of each intermediate action. GA Rollback explicitly installs that judge and gives it the authority to rewind.
Okay, walk me through how it actually works.
The generator is the one acting in the environment, clicking, moving, calculating. After each action and observation, the assistant analyzes the growing trajectory. If it detects an erroneous or just suboptimal move, it writes feedback and instructs a rollback to a specific earlier state. The system resets the environment to that point by replaying the action prefix. Then the generator continues from the corrected state with the assistant's guidance.
And how do they keep the assistant from overreacting, like flagging everything?
Two simple but practical controls. First, a confidence check on the assistant's own feedback. They compute how sure the assistant is. Think of it as averaging the probabilities of the words it wrote. And if that confidence is below a high threshold, the system ignores the feedback. Second, something they call wait info. In embodied tasks where the agent needs a little exploration, the assistant stays quiet for the first few actions. That way, it doesn't jump in too early and trigger noisy rollbacks before there's enough context to judge.
Nice. So the assistant doesn't hover. It waits until there's enough signal. How many steps are we talking about?
Roughly half a dozen actions before the assistant weighs in, and they cap the number of rollbacks per task to avoid infinite back and forth. The exact numbers can be tuned, but the idea is gather enough evidence, then intervene decisively.
Where did they test this?
3 standard agent benchmarks, Game of 24 for math reasoning, WebShop for web navigation and shopping, and ALF World for household-style embodied tasks. For WebShop and Game of 24, they evaluate on a few hundred sampled instances, and for ALF World, they use the out-of-distribution test split.
And what did they compare against?
Classic baselines act only, chain of thought, and react. They also look at reflection, which is a popular multi-trial self-improvement method, and then combine GA rollback with these methods to see if it plays nicely.
So, did the new framework actually move the needle?
Yes, GA rollback alone generally beats act only, OOT, and react on success rates across models. It shines even more when paired with reflection. You get the intra-trial safety net from rollbacks, plus the across-trial learning that reflection brings. One nuance. On WebShop, GA rollback improves success rate, but sometimes lags a bit on reward, meaning it often completes tasks, but may not always pick the absolutely best item unless reflection is also in the loop.
Interesting. And how does it behave with React?
That pairing can be unstable. If React produces messy internal thoughts, the assistant may flag too much or flag the wrong thing, leading to friction. The paper even shows a conflict example where the two styles of reasoning talk past each other.
What about cost? Replaying environments and having an extra model sounds expensive.
There's overhead. You're generating feedback, you're resetting environments, and you're writing longer explanations. Compared with a tree search baseline like 2OTBFS on the math task, GA rollback gets higher success rates with roughly around twice the tokens and something like a 1.5 times runtime bump on average across models. In exchange, you get targeted error repair rather than exploring a giant search tree.
Makes sense. Did they do ablations to check that the knobs matter?
They did. Removing the confidence filter or the wait info gate hurts performance, and stripping out the assistant collapses the method back to something like act only with a big drop in success. They also tried assistants of different sizes and found, unsurprisingly, that a stronger assistant can reason more deeply and help more.
Any tricky details in the setup we should keep in mind?
A couple. For the game of 24 task, they slightly modified the environment so it returns an observation after each action, necessary if you want precise rollbacks. Also, in most runs, they use the same model for generator and assistant, which simplifies engineering but leaves open the question of how well a cheaper assistant would do.
Right, that's practical. If I'm deploying this, I might want a small verifier watching a big actor, not two big models all the time.
Exactly. The authors frame GA rollback as plug and play, and it seems flexible, but the cost and pairing choices will matter in real systems.
Let's talk limitations. Where does this struggle?
First, long embodied trajectories remain hard. Even with weight info and confidence filtering, AlphaWorld isn't fully solved. Deciding which pass step to roll back to gets cognitively heavy as the trace grows. Second, the confidence threshold and the weight length are tuned empirically. That works, but a fixed threshold can be brittle across models or domains. Third, some real environments simply don't support clean rollbacks. Think of websites with irreversible actions, so the method needs extra guardrails there.
And reproducibility or sample size concerns?
The test sets are reasonable for agent papers, but not massive. More seeds and more websites would help. And that game of 24 tweak means direct apples-to-apples comparisons need care unless others adopt the same interface.
Okay, let me play back the essence to check my understanding. The paper says, instead of letting one long thought stream snowball mistakes, split the job in two. The generator acts. The assistant audits each step, and when it's confident something went wrong, it rewinds to that earlier point and steers the agent onto a better path. To keep this sane, the assistant only speaks up when it's highly sure and after the agent has done a few actions, so it has real context. The result is fewer cascading errors and higher success on common agent benchmarks.
That's it. Think of it like a chess coach who occasionally stops you mid-game, rewinds 3 moves and says, "Here's where it drifted. Try this line instead."
What would you like to see next from this line of work?
3 things. 1, learn the rollback policy instead of hard coding thresholds. Decide not just when to intervene, but how far to roll back in a data-driven way. 2, explore heterogeneous roles, like a lightweight verifier assisting a heavier actor, to trim cost. And 3, extend the idea to longer, messier tasks, maybe with variable weight schedules or multi-assistant setups, and standardize rollback-friendly interfaces so different papers can compare cleanly.
And a final takeaway for listeners?
GA rollback is a neat, practical framing. Give your agent a co-pilot with a rewind button. With a couple of simple controls, confidence filtering, and a short wait before judging, it cuts down on error propagation and plays well with methods like reflection. It's not free and it's not magic, but it's a promising step toward agents that can notice their own drift and correct course in the moment.
Nicely put. That's GA Rollback from EMNLP. Thanks for walking us through it.
Thanks, Maya, and thanks to everyone listening. We'll see you next time on AI Podcast.